Hi guys, today we're going to learn about the natural log function and integration. In the previous lesson we learned that the derivative with respect to x of natural log of u is equal to 1 over u du dx. So the corresponding integration formula is going to be the integral of 1 over u du is going to be equal to natural log of absolute value of u plus c. So how does it look like in this example? So the first thing that you're going to do here is you're going to pull out the 2 so you can use properties of integrals, okay? So we're using here the properties of integrals that we learned before. Now, next thing that we are going to do here, you recognize that this is pretty much the same as this. The only thing that changes is instead of u's, you have x's. So this is going to be equal to 2 natural log of absolute value of x plus c. So after that you can see that this 2 you can actually express it like this. Why I took out the absolute value of this problem here? Because you know that x squared, it's a guarantee that you have a positive inside the natural log. So that's a fair game, okay? You can leave it like this, but you can also express it like this. Now, let's look at this problem here. You have the integral from 1 to e of 2 divided by x dx. So technically speaking, you have the same as this one. So we can reuse that. Let's say that you have this, okay? But here we're going to evaluate from what? From 1 to e. So what you have here is you have that this is going to be equal. We can take out 2, okay, as a common factor. So you have natural log of e minus natural log of 1. Now, from algebra 2, you do know that the natural log of e, is just 1, and the natural log of 1 is going to be 0. So this is just going to be 2. Okay, isn't that simple? So that's what you need to remember from algebra 2. Okay, let's look at more examples over here. We have 1 over x, 2x minus 1. Okay, we want the integral of that dx. So what are you going to do here? What you need to do here is recognize that the u is going to be 2x minus 1. So for this, you need to recognize that we do need to do u substitution. So the derivative of that is going to be what? 2 dx. So you don't have the 2, but you can divide both sides by 2, so you can make it happen, okay? So you can put the 1/2 here, okay, if you prefer. And then you have that this is going to be the integral of 1 over u du. The du would be divided by 2, but I already pull it out here, okay? So this 1/2 that you have here, you have it here. After that, you can easily integrate the situation as 1 over 2, and then you have that that's going to be what? Natural log of absolute value of u plus c, okay? So is that it? Well, we need to always go back to your original, and in this situation you have that this is going to be 1/2 natural log of what? This is going to be absolute value of 2x minus 1, close it, plus c. Okay, so that's what we have. Okay, of course you can put this as an exponent, that's also an option. Okay, the next one that we have over here, you have the integral of 3x squared plus 1 divided by x cubed plus x dx. So what are you going to do here? So here you need to think about what's going to be your u in this situation. Well, it seems that the exponent in the denominator is higher, so it's very likely that that should be my u. And look, we are correct here because what do you have that it's the derivative of that? That's 3x squared, which is great, plus 1. That it's exactly what we have here at the top. Okay, so times dx. So you can recognize that we have this here, okay, exactly what we want. So I'm very happy there, okay? So you have that this is going to be the integral of what? 1 over u du, okay? So we have the situation, and now you can just apply the formula with the natural log, so it's here for saving the day pretty much. Okay, so you have this, okay, then we replace the u for what? In this case it was x cubed plus x, and leave the absolute value there because this is an odd function, so you never know what you can get inside that. Okay, so that would be my final answer for this problem. Okay, so let's look at another one over here. So again, you are like, okay, so I need to use u sub. Yes, you are right. So what's going to be here your u? Your u is going to be 1 plus natural log of x. So what's the derivative of that? That's going to be, well, this is a 0, but the natural log of x is going to be 1 over x dx. Do you agree with that? So at this point, you are like, wow, I do have limits of integration. Can I change my limits of integration? Yes, you do. Okay? So I have that. My lower limit, what's going to be your lower limit? You are going to take the 1, plug it here. So you have that 1. I'm going to put it here. 1 plus natural log of 1 is going to be 1 plus 0. So this is 1. And your upper limit, okay, your upper limit here, that it's e, what are you going to do with the upper limit? You plug it here, okay, so you have that it's 1 plus natural log of e. What's natural log of e? That's 1. So we have a 1 plus 1. So this is going to be a 2. So you are very happy because you can change the limits of integration to 1 and 2. And then you have that this is u power 3, and then the derivative, you can see that 1 over x is this one, dx, so you can see it here, okay? So you have the du over here, okay? Isn't that nice? So now this becomes pretty simple to integrate. So you're like, okay, this is going to be u power 4 divided by 4, so it becomes a simple one polynomial term there, okay? And you just plug the 2 and the 1. The beauty of this method is that I don't need to go back to any other log because I already changed the limits of integration. So I'm saving you pretty much to plug back into the log and, you know, like 2 steps, okay? So you can compute that, that's a 16 over 4, which I'm going to leave it like that because that's a 15 over 4, and that's your result. Isn't that nice? That's for that. Cool. Okay, so let's move on to another problem over here. So you can see that this problem over here, it's fairly similar to this one. Okay, so what's your u? In this situation, your u is natural log of x, and you can say that it's that one because you can see the derivative of that. Okay, so the differential more than the derivative. Okay, so you have 1 over x dx, which you do have it here. Okay, so you have it there. Now again, since I'm seeing the limits of integration, I'm going to change them again. So my lower limit, I'm going to plug my lower limit, okay, so the e here. So this is going to be a 1, right? And the upper limit that you have is going to be a natural log of e power 2. You know that properties of logarithms, you know that the 2 comes down, so this is going to be just 2, okay? So pretty neat. You have that your new limits of integration are 1 to 2. Then the u is going to be to the power of 4, and as we mentioned before, you have the du over there. So again, this is a beautiful one-term polynomial degree 4, so you can integrate that as u power 5 divided by 5, evaluated from 1 to 2. After that, you can see that it's going to be 2 power 5 divided by 5 minus 1 power 5 divided by 5, which you know that 1 power to the whatever is going to be 1, so I don't even bother to put the 5 there. Okay, so you know that this is going to be 32 over 5 minus 1 over 5. That's going to be 31 over 5, and that's it for this problem. Isn't that nice? So in this example, we have to compute the integral from 0 to 3 x squared minus 5 divided by x plus 2 dx. So the first thing that you would think that it's natural is to use a u substitution. Okay, the first u that I would think in this situation, it would be x squared minus 5. And then the derivative, the differential, is going to be 2x dx. You don't have it anywhere, so that's not going to fly well. The second option that you have is this u. You might think about this one as your u, the denominator. It would be x plus 2, but then the derivative, it would be just 1 dx, which it's pretty much useless, as you can see. So if you're integrating a quotient and the power of the numerator is greater than or equal to the power of the denominator, what we're going to do here is we're going to divide, okay, the polynomials, okay? That's going to be your option, okay? Divide polynomials, you're going to tell me, what? Are we in Algebra 2? So, yeah, pretty much yes. Let's take a trip to Algebra 2. So you have that it's going to be x plus 2, okay? And then the one that we're going to divide is x squared plus 0x minus 5. Why I have this one? If you remember from Algebra 2, I need to save the space, okay, for every single degree that we have, okay? So having this, then you are like, okay, I'm going to pretty much focus on this x squared. I want to make this x and x squared, so you have that x times x is going to be x squared. Positive outside goes negative inside. then x times 2 is going to be 2x positive outside goes negative inside. So over here we have that this cancel. Okay, as you can see that cancels, therefore what do you have? You have the negative 2x, drop the negative 5. Okay, after that, what are we going to do? We focus on this guy, so you want to this one to become a negative 2x. Okay, so you have the negative 2 there. Okay, so negative 2 times x is going to be negative 2x. It comes positive inside. Negative 2 times positive 2 is negative 4 outside, comes positive inside. Okay, so over here you cancel this, and your remainder is going to be negative 1. So now what happens? We can rewrite this with the new equation that we have. Okay, so you have that it's the integral from 0 to 3, because I haven't changed any limits of integration or u or anything, right? I'm just rewriting this. It's going to be x minus 2 minus 1 from here divided by x plus 2 and all of this dx. Okay, so what you can see now is that this integral is going to be x squared divided by 2. This integral over here, the integral of negative 2, is going to be what? Negative 2x. The integral of this guy is going to be negative natural log of x plus 2. Okay, and then you are going to evaluate all of this from 0 to 3. Okay, so what are you going to do next? You plug the 3 here, so you have 3 squared divided by 2 minus, and you have that's 6. Minus natural log of 5. I took out the absolute value because I already know that 5 is positive. After that, you plug the 0 here, which is a 0, the 0 here, which is a 0, and the 0 here, which you know that it's negative natural log of 2. So you have this. Okay? You could also express this situation that we have over here as natural log of what? 2 divided by 5 minus 3 halves. Why? Because you know that negative and negatives makes this positive. Having this natural log the same base, you can combine them as this one, and the other one, well, you can add the numbers. Okay, isn't that nice? So let's move on to 4 more integration formulas that we're going to learn. The first one that we have over here is tangent of u du. It's equal to negative natural log of absolute value of cosine of u plus c. Then the next one that you have here is the integral of cotangent of u du, that it's equal to natural log of absolute value of sine of u plus c. The next one, integral of secant u du, is equal to natural log of the absolute value of secant u plus tangent u plus c. And last but not least, you have that it's going to be the integral of cosecant u du, and it's going to be equal to minus natural log of cosecant of u plus cotangent of u close the absolute value plus c. Why these are true? Let's try tangent. Okay, so you know a tangent from pre-calculus. You know that tangent is going to be sine over cosine. Okay, so you have this. Okay, so what we're going to do here is we're going to do a little u sub like we have been doing in the previous examples, and your u in this case is going to be cosine of x because it's in the denominator. You have that du is going to be negative sine of x dx. So the only thing that you need to fix here is the negative du sine of x, okay, because you do have it here. Okay, so what you have is what? Negative. Okay, so you can put the negative here. That's this negative over here. Okay, what's that? 1 over u du. And you know that the integral of that situation is going to be negative natural log of absolute value of u plus c. Then what you're going to do now is you just replace the u for the actual equation, which is cosine x, and then what happens here? Wow, we got exactly the same thing. Isn't that nice? Now, the next one that we have over here is not as trivial, okay? So, because you're going to tell me, oh, this is 1 over cosecant, but it's not going to fly the same way. So, the way that mathematicians figure out this proof is the following. You have to multiply by a magic 1, okay? The magic 1 that we're going to have, you have your secant x here, okay? And the magic 1 that you have is going to be pretty interesting. It's going to be secant x plus tangent x divided by secant x plus tangent x, okay, and all of this dx. Let me put my ruler here so you can see this situation, okay? So you have this, okay? So what happens here? You're going to multiply this times the secant and this times the secant, okay? So what we have resulting in this situation is the integral of secant square of x plus tangent x secant square secant x. So you have secant x plus tangent x dx. So what happens here? Okay, so what you're going to see here is a pattern, very wacky, okay? So you're like, what should we do? Okay, so my u is going to be what? You are like, if I have u to be secant x plus tangent x, what is the derivative of secant x? The derivative of secant x is secant x tangent x. And then the derivative of tangent x is going to be secant square of x. So you can see that this becomes a beautiful situation. Why? Because all this guy that we have over here is what we have here. So then this becomes an integral of 1 over u du, and that's pretty much it. Okay, because from that you just apply the formula of the natural log. Okay, having this, therefore what you have here is going to be equal to natural log of secant x plus tangent x, close the absolute value, plus c. And that's what we have. Isn't that super interesting? So the next one that we have over here is the tangent of the integral of tangent of 3x dx. So what are you going to do here? The first idea here, obviously, it's going to be, well, I don't know if it's obvious for you, but maybe, is doing u substitution with the 3x. After that, you have that the derivative of that is 3 dx. So you don't have the 3, so we're going to divide both sides by 3. So you have that this is going to be 1/3 of the integral of tangent u du, okay? So what you have here is pretty much an application of the first formula that we learned. So it's going to be 1/3 of what? Negative natural log of cosine of u, okay, close it, plus c, okay? So what are you going to do over here? Well, you're going to replace the u for the actual value. So you have that this is going to be equal to negative 1/3 natural log of cosine of 3x, close it, plus c, and that's going to be your answer for this problem. Is that okay? Well, I hope that you find this video helpful. Bye.